how a look around. Seriously, the device you're watching this on right now, the medical tech that keeps us all healthy, the very future of clean energy, all of it depends on building things at a scale that is just mind-bogglingly small. This is the wild world of microfabrication, and today we're going to dive into one of its coolest and most clever techniques, hot embossing.
So here's the big question. How do you actually build something with parts that are smaller than a living cell? You can forget about the usual factory with all the sparks and clanging metal. We have to go somewhere else entirely, somewhere way cleaner, quieter, and, well, infinitely more precise.
The answer, believe it or not, is probably sitting in your pocket right now. You know that incredibly complex little stack of lenses inside your phone's camera? Or the microscopic sensors that tell your screen which way is up? Yeah, all of that is made possible by this kind of invisible manufacturing.
But it goes so much further than just our gadgets. This technology is right at the very heart of a revolution in medicine. It's enabling incredible things like lab-on-a-chip devices that can run a whole battery of complex diagnostic tests from just a single drop of blood. It's amazing stuff. And if we look ahead, this is exactly how we're going to solve some of our biggest challenges. We're talking about squeezing every last drop of power out of a solar panel or designing way more efficient fuel cells. The scale might be microscopic, but the impact? Oh, it's absolutely massive.
Okay, so to really get how this all works, we need to adjust our thinking. We need to enter a world in miniature.
I mean, we are talking about building structures so incredibly tiny that they make a single human hair look like a giant redwood tree. To pull that off, you need a manufacturing process that is both ridiculously precise and, at the same time, ready for mass production. And this is where a brilliantly simple, yet incredibly powerful technique enters the picture. Let's talk about hot embossing. So what is it exactly? Well, think of it like a super high-tech stamping process. You take a special mold that has a microscopic pattern carved into it. You heat up a polymer material till it gets all soft, and then you just press the stamp in. What you get is a perfect, tiny replica.
You know, the absolute best way to picture this is to think about a waffle iron. No, really, you pour in the soft batter, you press down the patterned mold, you add some heat, and pop! Out comes a perfect grid. Hot embossing is the exact same idea. We're just swapping out the waffle batter for advanced polymers and creating patterns thousands upon thousands of times smaller.
All right, let's break down that micro waffle making process step by step, because in this process, the magic is really in the details. First up, you heat a sheet of polymer, something like PMMA, which is basically a fancy type of acrylic, until it gets soft and really moldable. Second, you press a master mold, or a stamp, right into that soft polymer with very, very carefully controlled force. Third, while you're still pressing, you cool the whole thing down, which hardens the polymer and locks that intricate new shape in place. And finally, you release the mold, and what you're left with is a perfect, high-fidelity copy. It's simple, it's elegant, and it is unbelievably effective.
So, what can you actually do with this microstamping process? Well, as it turns out, you can build some of the most critical, high-tech components that make our modern world tick. I mean, the range of applications here is just staggering. We're using it in optics to shape light itself with tiny lenses and sensors. We're creating microscopic plumbing for microfluidics, which is revolutionizing medical testing. It's at the absolute core of new electronics and energy solutions, everything from brighter LED panels to better fuel cells. And we're even designing smart surfaces that can repel ice or even change shape on command.
Let's just take optics for a second. You know that shiny security hologram on your credit card? Yep, that's made by embossing a diffractive grating that basically plays tricks with light. By stamping these microscopic patterns, we can also make LEDs way brighter and solar cells more efficient. It even works on really specialized materials, like chalcogenide glass, to create the infrared optics that are essential for night vision.
Now this is where things get really life-changing, especially in medicine. Microfluidics is basically plumbing, just on a microscopic scale. And hot embossing is how you carve out all the tiny channels for the fluid to flow through. These lab-on-a-chip devices can sort cells, mix tiny amounts of fluid, and perform complex analyses, all on a single disposable chip. It's a tiny revolution.
So just how small are we talking here? Well, researchers have used this exact method to create channels that are just 55 micrometers deep. Now, to put that in perspective, a single human hair is about 70 micrometers wide. We are literally engineering structures that are narrower than a strand of your hair. It gives us this incredible control over the tiniest amounts of fluid. And the impact on energy and electronics is just as huge. I mean, think about flexible screens for our phones. Those could be made by embossing a microscopic silver mesh right into a polymer to conduct electricity. Or get this, imagine airplane wings that literally can't ice over because they have a special microtexture stamped onto them. This technique is building those kinds of advanced surfaces right now, along with the critical internal structures for next-generation fuel cells.
Okay, so if you thought 55 micrometers was small, you might want to brace yourself. We can go even smaller. Hot embossing has been used to create channels just 188 nanometers wide. We're not in the micro world anymore. This is the nanoscale. That is hundreds of times smaller than a single red blood cell. That's the level of mind-bending precision that is pushing the absolute boundaries of what we can build.
So, when you put this all together, it becomes crystal clear that this ability, the ability to shape matter on this incredibly tiny scale, is one of the fundamental engines of modern innovation.
At the end of the day, the power of this microstamp comes down to 4 key things. 1, it gives us incredibly high precision, right down to the nanometer scale. 2, it's super versatile. It works with all sorts of polymers and even some types of glass. 3, it's scalable, which means we can use it for mass production. And 4, because of all that, it's a key that is unlocking countless new innovations across science, medicine, and tech.
And that just leaves us with one final big thought. We've seen how this technology is shaping our world today, from the phones in our hands to the labs in our hospitals. But the real question is, what's next? What will we be able to build when we can precisely shape almost any material at any scale we can possibly imagine? The possibilities, it turns out, are both truly microscopic and absolutely massive.